So the title of my seminar today is Internal Combustion Engines Development, Testing and Emission Control Technologies. So to give a brief about myself, I am the Technical Innovation and VAV Consultant. So prior to that, I was working in companies like Bharat Earth Movers Limited, BEML, Mahindra and Mahindra, BSA, Avtech Power and Private Limited. So I have a wide range of experience in automobile field. Currently, I'm also a Southern Council member in Indian Value Engineering Society, and recently I was also been appointed as a director in Miles Valley Foundation, located in USA. Give more about this Indian Value Engineering Society. You can also look into the website. It's also a parallel society like the SAE, Society of Automobile Engineering. But here, as you know, this SAE is mostly concentrating on the automobility, but this Indian Value Engineering Society is concentrating on all the sectors. And again, it will be very useful for mechanical students as well as for the faculties. You can also become a member, or you can also be a part of that. Can guide you. And the father of value engineering is A.D. Miles. Under his name, they started the foundation. It's helping for promotion, advocacy, certification, and education with respect to the value engineering. And the name of the foundation is Miles Value Foundation. And it is located in USA. You can also check the details here. Last week, I was been appointed as a director to serve the Miles Valley Foundation, dealing with the value engineering aspects of all sectors in India and also in Asia. Okay. The first 1 hour, I'll just give some brief. As you know, all you are from mechanical background. I want to touch upon some basics about. I request all to put it in mute actually. I think Mr. Prabhu Subramaniam sir had raised a hand. Can you please tell me, sir, you want anything? Hello.
Sir,
Yeah, it is hearing. Very
audio
clear.
quality is not clear.
Sir, Arjunraj, sir.
Yeah.
Sir, our principal, sir, is online, sir. Ramesh, sir. Hello.
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 Yeah, Michael Raj, sir.
Yes, yes. Ask everyone to mute their speaker. Hello. Hello.
Okay, let Ramesh sir join parallelly. So, can I start, sir? Hello?
You can start.
So, I'll start with the basics, then I will go with slightly detailed math. As you know, the law of conservation of energy, which you might have studied in a subject called physics, law of conservation of energy states that energy can neither be created
Hello,
nor be destroyed, but it can be transformed
Malayali Sarinadu.
from one form of energy to another form of energy. So here in engine, also the law of conservation of energy taking place. Because you know, the gasoline and the diesel, they are the two form of fuel which is having the chemical energy in it. Okay. I request everyone to mute actually because I'm getting disturbance to take seminar. Okay, so as I said, the law of conservation of energy is happening in engine. So engine is a machine in which the chemical energy out of fuel is converted to thermal energy, and in turn, this thermal energy is converted to mechanical energy. So when I say law of conservation of energy, the energy can neither be created nor be destroyed, but it can be transformed from one form of energy to another form of energy. So here, as I said, the gasoline is having the petrol, which is nothing but a chemical formula or chemical energy. Similarly, diesel is also having the chemical energy in it. When petrol or diesel is into the vehicle, what happens is that we are getting the heat out of that by burning the fuel. Heat is nothing but a thermal energy, and in turn, when heat is getting developed, what happens is that the camshaft, crankshaft rotates, and finally we are getting the output, which is nothing but a mechanical work. So here there is a conservation or the conversion of energy taking place from chemical to thermal and then thermal to mechanical. So how I can define engine? Okay, I'm going to define engine as a machine which converts the chemical energy out of fuel into thermal energy and thermal energy into useful mechanical work. So all machines cannot be an engine, but all engines can be a machine. Okay. So even in machines, the conversion or conservation of energy is taking place. Yes, you might know many machines. It can be either a CNC machine or the advanced level of machines which we are using it for the mechanical or chemical work or even electrical electronics activities. So here you might have seen in machines, even in machines also, we are getting the output as mechanical or as an electrical or as a chemical thing. Chemical process engineering machines will give output as a mechanical as a chemical energy as the output, and mechanical machines will give the mechanical work as the output, and the electrical machine will give electrical work as the output. In the case of machine, what happened is that there also the conservation of energy or the conversion of energy takes place. I can define engine as a machine, but all machines cannot be an engine, because in machines you have a lot of other energy apart from the chemical, thermal, mechanical, like you have the electric energy also. So that's why all engines is a machine, but however, the vice versa is not possible. All machines cannot be an engine. So when anybody is asking the students to define as energy or engine definition, you have to define such a way. You should consider the three type of energy in your mind when you're giving a definition. So you have to consider chemical energy, thermal energy, and mechanical energy or mechanical work as the three type of energy in your mind. So you have to define engine is the one which converts the chemical energy of the fuel into thermal energy, and then that thermal energy is into the useful mechanical work. And you should always keep engine in your mind, that engine is a machine. Okay. So you define the engine in this way so that it will impress the people also. Okay, even and when somebody is asking you to define the in interview or something, you can define the engine in a more elaborate manner like this. Okay. So you know two type of engines. One is the internal combustion engine, and the one is the external combustion engine. So in automotive thing, we'll deal with internal combustion engine. So an internal combustion engine is defined as a device in which the chemical energy of the fuel is released inside the engine, and it is used for doing the mechanical work. This I already defined you. As in the case of external combustion engine, you have the separate combustor which is used to burn the fuel. Okay. See, this is quite interesting. Okay, so I'm going to compare the part of an engine with the human body. We have leg, okay? Human body is having leg. The leg for an internal combustion engine is the cylinder block. Okay, we have the heart for a human body. Similarly, the heart of the engine is the piston assembly. Piston is having a piston ring, piston pin, and a piston assembly. The piston itself. We have the nose to breathe the air in. Similarly, intake manifold is the one through which the air is being entering into the combustion chamber. In the case of diesel and in the case of gasoline, air and fuel mixer. We have the head. Similarly, the head for an engine is a cylinder head, which is located at the top. We also have the hair above the head, and that is for basically for protection. Similarly, the engine will have the cylinder head cover, which is not mentioned here. We have different type of system in our human body, like the digestive system, respiratory system, circulatory system, reproductive system, and we have different type of systems. Okay. Similarly, engine is having different type of system like the cooling system, lubrication system, valve train system, crank train system, intake system, exhaust system. So when someone is dying, when anybody is dying or something, when any human body is found dead, what normally people do is that they do some post-mortem to find out the reason why the particular person had died. Similarly, in companies, what we do is that we do some the reason for the engine failure or the engine getting died. So when there is any issue or when the engine is not working or when there is any failure, we try to analyze the reason for the failure. We try to look into it and we do the tear down, which is nothing but a post-mortem what we call for a human body. We try to do the reason for the engine failure or the engine getting uh, not it is not working. So this is how I am going to compare the engine with the human body. We take water to cool our to cool our internal parts. Similarly, we need to have the coolant for a engine, and we also need to have the engine oil for the lubrication purpose. So here, the coolant is normally ethylene glycol along with water, 50% or 60-40%, whatever the combination is. So this is just a basic. Then I will go with the main topic of how we are reducing the emission control technologies. So emission control technologies is possible to reduce in SA engine or SE engine by two ways. One is with the help of the internal structure inside the engine, and the second one is that by using some external after treatment. And the third one is also possible with the help of the fuel. So if you are having the high level of the fuel, either a gasoline or a diesel, having a lesser sulfur content, less than 10 ppm, then we can achieve the lesser emission. So here, first I will just give some basics about the difference between the compression engine and then the spark ignition engine. I think you might have studied in a subject called thermal engineering, the basics difference. But I will also highlight once again so that it will be a refresh kind of thing for you. So when I take the compression ratio, it is nothing but the ratio between the total cylinder volume to the top of the clearance volume, Vs plus Vc by Vc. You would have studied the difference or the definition of a compression ratio in a thermal engineering. So here, the compression ratio for a CA engine or a diesel engine is much more higher than that of a SA engine or a gasoline engine. So here, the compression ratio cannot be much higher than 10.5:1 or 11:1 in the case of a gasoline engine because you tend to have the knocking sound. Okay, it's like a sound which will come when you are increasing the compression ratio beyond that particular thing, and also it will result in abnormal combustion when you are increasing the compression ratio beyond that. And it's not only the knocking sound, but it will tend to have abnormal combustion, which will overshoot the compression ratio is higher. So this is the reason why it is limiting to 10.5 or 11:1. Whereas in the case of I request everyone to put it in mute because I'm The first difference is with respect to the combustion ratio, and the second, as you know, we have the compressor ignition in the case of CI engine and the spark ignition in the case of SI engine. See, the thermal efficiency, okay, it is much more higher in the case of the CI engine or diesel engine, and it is very lesser in the case of the spark ignition engine or the gasoline engine. And you know, the initial cost, you see this another the very important thing is the cost. The initial cost of a diesel vehicle is much more higher, okay, and the cost of a petrol is lesser when compared to the diesel. Maybe 1 lakh difference will be there. And you know, when I say when you're going to reduce the emission, it is possible in two ways. One is by the initial internal structure of the engine, and the external feature by adding after treatment. When you want to achieve the emissions like Euro 6 in the case of diesel, you need to go for after treatment. It will cost additional cost of maybe 50,000 range or 1 lakh range. So as you know, the cost of the diesel is much more higher already. This will additionally add extra cost. That is the reason why the people, OEMs, are concentrating on the diesel or on the petrol engine rather than the diesel engine. But the case of the heavy duty vehicle like the trucks, tractors, still they are going with the diesel because the mileage is again issue for them. Okay, so and again the mileage, the fuel consumption will be less. The mileage will be higher in the case of diesel, and fuel consumption will be lesser. That is the reason why they are still for the heavy duty or the commercial vehicle they want to go with the diesel rather than the petrol. And again, for long run, even diesel will be good. And again, nowadays the cost of diesel is lesser than the petrol, but still there is a possibility the diesel cost will be slightly come equal to that of petrol in near future because the manufacturer have to reduce the sulfur content in a diesel to achieve the Euro 6 of 10 ppm sulfur content in it. So still the cost of the diesel will still go higher, and it may come closer to or near to or sometimes at par with respect to the petrol. So hence the this is the reason why even the company is also looking into the aspect to manufacture a petrol engine rather than the diesel with respect to the passenger car. But with respect to the heavy duty or the commercial vehicle, still there is no option that diesel is the way.
No, I can't.
So for me, it is very difficult to admit every time everybody. Okay, so still I will manage. So you know the horsepower, okay? So the unit of horse or the unit of engine is measured in horsepower. So we have the muscle power, okay? For a human body, it's a muscle power. We have similarly the horsepower is a unit of an engine, okay? How I can define the horsepower? 1 horsepower is nothing but 33,000 pounds or foot-pounds per minute. So assume this is the horse, okay? Assume this is the horse carrying a coal, okay? So when this horse is moving by carrying the coal, or I can tell, assume this horse is a human body. When you assume that the human body as me, when I am carrying the coal of having the weight of 330 pounds, okay, I'm carrying 330 pounds of coal at my back, and I can walk 100 feet in a minute, okay? So you can see the difference. Like it's not 1 feet or 2 feet; it's 100 feet. I can walk 100 feet in a minute, not by alone, but I am walking by carrying a 330 pounds of coal. Uh, if I'm not carrying 330 pounds of coal, instead that if I'm carrying only 33 pounds of coal, then I can walk 1,000 feet in 1 minute. Or I can say, instead of telling a walk, I can tell I can reach 1,000 feet in a minute by carrying 33 pounds of coal with me. Okay. Or when I'm carrying, instead of 330 pounds or 33 pounds, if I'm carrying only 1,000, if I'm carrying 1,000 pounds of coal, 1,000 pounds of weight, you can also convert pounds into weight or in terms of kg or gram. Basically, kilogram you can convert, and you can see this much weight I'm carrying, and I'm walking 33 feet in 1 minute. It's easy to walk 33 feet in a minute, or even 1,000 feet in a minute, or 100 feet in a minute. It is possible to reach if we do not have any weight with us. But you see, the horse, or I'm carrying the weight, and then if I'm moving that particular location to location, is highly impossible. Okay. So many engines having 100 horsepower, 140 horsepower, 90 horsepower, 80 horsepower, etc. You multiply it by 100 or 140. So you see, when I say the power of 1 horsepower itself is this much, then you can say, if the engine is having 140 horsepower, I worked in the many engines ranging from 65 to 140 horsepower I have worked. So when I say 140 horsepower, yeah. When I say 140 horsepower, you need to multiply this with 140. So I can say I can reach 1,40,000 feet in 1 minute by carrying the weight of 33 pounds of coal. You see, this is the real horsepower, okay? But this is highly impossible because we have a lot of traffic issue, and but most of even the race car is not experiencing this. Yes, even in race car also you have a lot of turnings, and you have a lot of curves. It becomes very difficult. And again, turning the vehicle at high speed is also highly impossible. Okay, so normally in company, what we do is that we need to design the engine. So here we do some design calculation using the ratio called R. Okay, R is nothing but the ratio between the canting rod length. So engine is having the different components like canting rod, crankshaft, camshaft. You have seen. So when I want to design any engine using the ratio called R, it is nothing but the canting rod length L, and then the crankshaft called A. So R is nothing but the ratio between L by A. So when the engine is smaller, the ratio will range from 3 to 4, and for a higher engine, the ratio will range from 5 to 10. Okay. When the engine size is larger, what happens is you are going to define the value of R as in between 5 to 10, and when the ratio is between 3 to 4, this is applicable for a small engine. I'm going to draw a graph between the crank angle of the engine in terms of degree with respect to the mean piston speed. It is nothing but it is denoted in terms of the velocity. Okay, it is nothing but average speed. Okay. So here you can see the effect of R with respect to the mean piston speed. So as I said, you are going to define or design any engine using the ratio called R. R will vary from 3 to 10, where 3 to 4 is applicable for small engine, 5 to 10 is for a large engine. So here, when I say the ratio of R is getting increased, okay, when R is higher, which means the canting rod length is higher. Okay, when canting rod length is higher, what happens is the canting rod is higher. When the length is higher, canting rod is one end is connected to the piston, another end is connected to the crankshaft. So when the canting rod length is higher, what happens is the mean piston or the average piston speed will be more, which will be lesser. Okay, it is like a smaller fan and a bigger fan. When the diameter of the fan is smaller and when the diameter of the fan is bigger, you see the mean speed or the average speed of the smaller fan will be higher than that of the bigger fan. Similarly, when the length is higher respect to the connecting rod, the mean average piston speed will be lesser. So that's why when R is 3, the average piston speed is higher, and when R is 10, it is lesser. So the graph gets reduced. Okay, so this is the general thing. So again, I need to design the engine using the cylinder surface area and then the cylinder volume. So any engine will have the cylinder volume and also it will have the cylinder surface area. So you know the formula to pi r L and pi r square L. So basically we also determine the bore diameter, the displacement volume, clearance volume. So all these are the general thing that normally we do in company. See, this is the graph showing the displacement versus the BSFC. So when the displacement of the engine is getting increased, the BSFC of the engine will be lower, which means the mileage will be higher, which means the fuel consumption will be lesser. So BSFC is normally generally decreases with respect to the increase in the displacement of any engine because there is a reduced heat loss is going to happen from the gas to that of the cylinder wall when the displacement of the engine is getting increased. This is the reason why the BSFC is getting reduced. Okay? When the heat loss from the gas to the cylinder wall is lesser, the BSFC will be lesser, which means the mileage will be more. So I told you have three type of energy: chemical, thermal, and mechanical. So when you are converting chemical to mechanical work, there will be a lot of losses which will happen with the help of or when the thermal energy is happening. Okay. So you know the theoretical action the cycle which says that 100% efficiency is possible, but nowhere it's possible to have 100% efficiency. If at all it is even if it is supernatural, it's highly impossible to have 100%. If we could able to achieve, then the law of thermodynamics will get violated. So we, as I compare the engine with the human body, we also have a lot of losses. So losses I can compare even with your percentage of your marks in subjects. So you might study some 10 subjects on an average in semester. So it is highly impossible for the students to secure 100 out of 100 on all subjects. Okay, it is highly impossible. Okay, there might be a lot of losses. It can be in the form of memory loss. You might have studied completely, but because of your memory loss, you may not score. Okay, so and again, you also have some time loss. You because of time constraint, you may not be able to attend all the questions respect to some of the mathematical letter oriented subjects. So this might be the reason for you not to score 100 out of 100. But similarly, in the case of engine, it is having a lot of losses because of that you cannot able to get 100% efficiency. So, and I also compared the efficiency of diesel with petrol, where it is possible to have 40% efficiency in the case of uh, diesel engine and only 20% is possible in the case of a gasoline engine. The reason behind that is the losses is happening when the energy is getting converted from chemical to mechanical work using the thermal, which is nothing but a heat. Okay, so here the loss is happening in the form of radiation, coolant loss, radiation loss, and also the exhaust loss. Okay, you have three type of power. One is nothing but the indicator power, the friction power, and brake power. So you know the brake power is nothing but the output power of the crankshaft. When you're measuring the power in the crankshaft, that power is nothing but a brake power. When you're measuring the power inside the cylinder, it is nothing but the indicator power. So how I can define the friction power? Friction power is the power which normally gets developed when the engine is running at a higher speed. The engine is running at red RPM or at high ideal RPM, or when the engine is much more at the rated speed. So this friction power mostly it will occur when the engine is running at higher RPM. So the brake power is defined as the summation or the difference between the indicator power to the out of friction power. Okay. There is also some the friction loss will happen when the engine is running at higher RPM. Pumping loss is nothing but the loss between the exhaust to the top of the intake. You know, intake stroke. You have intake stroke, compression stroke, power stroke, and then the exhaust stroke. And again, the cycle gets repeated. After the exhaust stroke, again the intake stroke comes. So there will be loss will happen between the exhaust stroke and the intake stroke. That loss you call it as the pumping loss. Normally we can measure the engine friction using the mean effective pressure, which is nothing but average pressure which is developed inside the cylinder in all four stroke. You have the effective pressure, the mean effective pressure will be there at each and every stroke. So when I say the average mean effective pressure, which is nothing but the summation of all the pressure divided by all the four strokes.
Online meeting.
So here, I method the friction mean effective pressure by using all the I think some people are not putting limit. Already time is 1 hour we are going to complete, but still I am very slow. I request you to put it in mute so that it do not disturb me. Okay. So the mean effective pressure, as I said, it's average pressure, which is getting developed inside the cylinder in all the four stroke. So I can measure the friction mean effective pressure using the indicator mean effective pressure, brake mean effective pressure. So you have other type of mean effective pressure, which is nothing but the auxiliaries, supercharger, the turbocharger. So all this will be the cumulative effect to determine the friction mean effective pressure in an engine. Higher the friction mean effective pressure, then you need to reduce the friction mean effective pressure. Okay, see this graph is quite interesting. You listen this carefully. See, when the engine speed, I'm taken it in x-axis and BSFC in y-axis. When I said the BSFC of the petrol is higher than that of a gasoline, than that of a diesel, sorry. So the BSFC, okay. When I say BSFC is lower, I can compare using the compression ratio. Here there are two compression ratio, one having 8, another having 10. 8 is the compression ratio shown in dotted, and 10 is the one having the compression ratio shown in the continuous line or the continuous curve. So when I take the dotted curve, the compression ratio is 8. You can see the compression ratio having 8 is having the more BSFC than that of the compression ratio having 10, which means BSFC will reduce. BSFC will reduce when the compression ratio is higher. It means the mileage will be more. This is the reason why the mileage of the diesel is more than that of petrol. The reason behind that is the compression ratio. Compression ratio of the gasoline mostly maximum will be 10.5 or 11:1. Whereas in the case of the diesel, the compression ratio will go from 14 to even 25, 22, 25 possible. And that is the reason why the BSF is much more lesser in the case of diesel, and that is the reason why the mileage is more for a diesel. Okay, so again, I'm going to derive two more information out of this graph once again. What is that two more information? Why this BSFC is lesser when the engine is running in lower RPM? That is the first information. And why the BSFC is more when the engine is running at higher RPM? So first, I will compare the higher RPM. Okay. When the engine is running at higher RPM, the BSFC is higher because, as I said, there is always a friction loss when the engine is running at higher RPM. Okay. Now I am coming to the lower RPM. Why the BSFC is more when the engine is running at lower RPM? Okay. When the engine is running at lower RPM, the BSFC is higher because there is an increased time for the heat loss from the gas to the top of the cylinder and then the piston valve. Okay. There is always a time increase will happen for the heat loss because the heat have to go from the gas to the top cylinder of the piston valve. The time it should be lesser, but the time will be more because when the engine is running in lower RPM, what happens is that the heat getting generated or getting dissipated will be slightly lesser, and again the travel time or the increased time will be more. Okay, this is the reason why the BSFC is much more higher at lower and higher RPM. So that is the reason why people try to run the vehicle or run the engine between the range of 2000 to 4000, depending upon the engine to engine or vehicle to vehicle. So most of the taxi people will be much more careful. They will not neither run the engine at lower RPM or higher RPM. They will run the engine between that, so that they will save the fuel. Okay. Oh. Okay, you have a lot of losses in a cycle, as I said. Because of that reason, you cannot able to get 100% gas standard cycle. So instead that you will get the actual cycle. So what are the different type of losses? You have time loss, heat loss, blow down loss, blow by loss, friction loss, pumping loss. So time loss, okay, when I'm injecting the fuel or igniting the fuel, what happens is that the time taken for the combustion to take place, that loss is the nothing but the time loss. Okay, when I'm injecting the fuel or igniting the fuel, the combustion will not take immediately. Okay, there will be some loss or the time it will take. Even the time is not in the form of second or a minute or a hour. The time is mutually in the form of microsecond, micro nanosecond. Even that there will be some loss. We do a lot of calibration to reduce the time loss so that we can increase the efficiency of the engine. And the next one is nothing but a heat loss. Okay, when the heat is getting dissipated, generated from the cylinder valve, from the piston to the top, the gas to the top of the piston valve or the cylinder valve, there will be some heat loss. Okay, and even the next one is nothing but the blow down loss. You know the valve timing diagram. You have the intake valve, exhaust valve opening, closing, and exhaust valve opens or closes well before the TDC, BDC, what we call. So there will be the sudden drop in the torque of the engine or the power of the engine, which is nothing but a blow down loss. This will also affect the actual cycle. Basically, it's not you don't consider the actual cycle, but in turn you can consider this loss will affect the efficiency of the engine. So the blow by loss, okay, you have the piston ring where the exhaust gas will pass into the piston ring, and there will be loss. That loss is nothing but a blow by loss. The next loss is the friction loss, which will occur when the engine is running at a higher RPM. And the next is the pumping loss. As I said earlier, pumping loss is the loss which is nothing but the difference between the engine when the engine is running between the exhaust stroke and the intake stroke. Okay. See, in older engine we have the rocker arm. Okay. The current is the screen is visible. Hello. Okay.
Yes,
Yes,
yes.
Yes,
Yeah,
sir,
it is very visible, sir.
Yes, sir.
Very,
Yes, sir. It's visible, sir.
Because what happened is see, I can move the cursor, right, but I'm hearing mute start video. Is this also visible for you? Mute start video security, that is not visible to you, right?
Yes, sir, that is not visible.
But it is visible to me, that's why okay.
You can enlarge, zoom out also. You can zoom in and zoom out.
Remote. 1 second, right?
You can increase the size of the screen also. Everyone from their mobile, they can increase the size. Just zoom in and zoom out.
Okay. So now what happened is that nowadays in older engine we have seen the push rod. This push rod is being replaced with the hydraulic glass. So here what happens? This hydraulic glass adjuster it will adjust the clearance. So again, in older engines you have the push rod where it will also tend to have a lot of more weight and also the noise will happen. But noise and then this is minimized with this hydraulic glass adjuster. So now I will tell you I think people have to put it in mute so that it will be easy for me.
உடம்பு பருப்பு இருந்தா வந்து சோத்துக்கு போனாலும் அவங்க கொண்டு விட்டு வந்து தண்ணி வச்சுட்டு சாயங்காலம் தெரியல சாயங்காலம் வர சொல்றேன்
I request you to put it in silent. So what are the different type of activities that we normally carry out with respect to the engine group in a company? Okay. So we have different department design, development, calibration. So in design department, what we do is that we do the concept design, we do the benchmark. We do the design benchmark. We do the prototype. And then what happens is that we also do the failure analysis. We do different type of testing. We do different type of calibration activity for performance development, emission development. When we do some of the environmental correction, drivability calibration, etc. So we do a lot of testing also. So here what we are doing is that we are ensuring that the engine reliability and the testing is also good with respect to the engine as well as engine along with the vehicle. We also do CIE, CFD. Similar, we do NVH. We do the engine assembly. We do the integration with the vehicle. So the design engineers, we do the calculation, we do the GD&T tolerance stackup, tolerance study, we do the weight reduction technologies. We try to analyze a lot of things. We do the drawing preparation, 2D, 3D, and we do the design benchmark, cost benchmark, performance benchmark. The performance and cost is very important aspect, even with respect to the value engineering also. So initially I was telling you about my role in value engineering. Even that technique will help in the company to reduce the cost and to also to increase the performance. So we do the other design activity. We do design for failure mode effective analysis. We do process flow failure mode effective analysis. We do design verification plan. We do the 2D, 3D prototype build. We do the testing also. In any the process or any product life cycle, we start with the design phase or a concept phase. Then need to go for a design phase. Then we do the prototype, where we do the minor tool correction. In the case of design, we do the drawing modification and earlier anything is that we detect. And after proto, we do the testing. After testing, we do the batch production, and finally final production we do. After production, if in case any customer complaints, we try to address it. See, we do different type of mechanical development activities in a company, where we do the failure analysis. We do different type of testing. Okay, we do cold tests, warm test, thermal cycle test. We also test with using sub-zero durability cycle, etc. So we do different type of testing. I will show you. So we do the high-speed test, which is nothing but the 150 hours test. This test is normally carried out when the engine is running at high speed. You can see the red in terms of the engine speed and the blue in terms of engine load or engine torque. So this test is for 150 hours and each cycle time is 20 minutes. So the test is basically meant for the high speed operation, where the engine will be held at higher speed. Even beyond 100%, you can see the engine is tested with 125% speed and 150% speed, which means beyond the rated speed, the engine is allowed to test in the worst case to ensure that there will not be any failure. Normally, we are doing this type of testing to ensure that the durability or the reliability of the engine is not getting affected. The next test is the rate of power test, where we do this test for 400 hours. These tests, we are doing it when the engine is running in the rated speed. So 90% or 95% of the time, the test will happen in the rated speed. And here we are doing the ramping up for a few seconds, and 90% of the time the engine will run in rated speed, and again we are ramping down. All these are basically a computer programmed one. So the next one is the cyclic load test. This test will be slightly confusing to you. Here we do this test for 1000 hours, which means when I'm completing this test without any failure, I can give assurance to the people that it will pass 2 lakh kilometer in a vehicle. So here we are testing the engine in minimum speed with full load, maximum torque speed condition, high idle condition, low idle condition. So with all the combination, we are going to test it. Here we are also loading the vacuum pump, compressor, water pump, alternator. We are going to load all the things. It is nothing but you are loading all your accessories and you are testing it in the worst case condition. Next test is the resonance durability test. The duration of this test is 400 hours. So this test is meant for ensuring that the vibration of the engine. Here the tests are even carried out at high idle RPM, which means beyond 100% of the speed. You can see the red and the blue, it will happen parallelly. So you can see when I'm increasing the speed, the load also getting increased. When I'm when it is going to the high idle, again the load gets reduced. So basically, we are trying to ensure that the vibration is also getting induced in such scenario. The next test is the thermostat test, where we test the engine in maximum heat input condition and the minimum heat input condition. When we are testing the engine in maximum heat input condition, what happens is that expansion will happen. When the engine is running in minimum heat input region, thermal contraction will happen. When it is running in the maximum heat input region, what happens is that
laptop. சும்மா இருங்கண்ணா.
I request the participants to put it in mute. Okay. So duration of the test for the thermostat test is 400 hours. When the engine is running in maximum heat input condition, what happens is that the thermal expansion will happen. When the engine is running in minimum heat input condition, the thermal contraction will happen. So we also do the cold start part load test. This is nothing but a test that we do for 1000 hours to ensure that the engine is running in maximum brake mean effective pressure condition, the maximum brake mean effective pressure, and in that condition, even the exhaust gas recirculation, that is, we are recirculating the exhaust gas into the intake manifold to reduce the nitrogen oxide emission and also to increase the performance of the engine. Basically, volumetric efficiency we are trying to increase. Here, what we do is that we test the engine in maximum brake mean effective pressure condition to ensure that even at the maximum brake mean effective pressure, the load will be much more higher, and in that condition also there is no effect to the engine. The next test is the piston and cylinder crankhead test, cylinder crack test. We do it for 500 hours. We have different type of driving cycle. One is the European driving cycle, Indian driving cycle, American driving cycle. So normally in European driving cycle, the average speed is 120 km per hour, whereas for India it is 90 km per hour, and for US it is 140 km per hour. We do this type of driving test to the engine along with the vehicle. We do it in chassis dynamometer. We also do some standard bench type cycle test with respect to time and air fuel ratio. So you have three type of air fuel ratio. Like one is rich fuel, lean mixture, rich mixture, and stoichiometric mixture. So rich mixture is the one where you have a higher amount of fuel and less amount of air. Lean mixture is the one you have less fuel and more air. Stoichiometric is the one where you have correct amount of air fuel ratio. We do this test against the time versus the air fuel ratio. We do this test